we started this error detection and correcting codes. So again, let us revise those things. Now suppose we are in place A. I'm sending some binary data from place A to suppose place B. Now suppose I'm sending 1010. Place B person doesn't know what I'm sending. Okay. So suppose here message is received 1010. So if I look both of these data, I can say that correct message is received in place B. Now suppose instead of that, suppose data is received 1011 or 1000, okay, or 0010, okay. So what happens if this kind of data are received? Is it the correct data? All this, are they correct? Whatever I am intending, whatever I am sending, is it correctly received? If I receive these things, they are not correct. So now take this three example and let me write another example. Suppose 1001. Can you identify the difference between this two? Both are incorrect, both are not correct. Apart from that, any other difference? Anyone?
So 2 bits are incorrect.
Okay, in fast 3 here, how many bits are incorrect?
So 1 bit.
One bit is incorrect. One bit is incorrect. Here, 2 bit is incorrect. So, while I'm sending 4-bit data, for example, so error in the place B, maybe error will be there in 1-bit position, or it is possible that error will be there in 2 bits. It is also possible that error can be there in 3 bit. It is also possible that error can be there in the all the bits. Okay. So first of all, what will happen? We'll try to identify the error. So what happens for that purpose? Parity bits are used. So what we used to do? You will go for a additional bit, which is called as a parity bit. Okay. Now what will happen? Whatever you are intending to send from place A, suppose I want to send here 1001. This is my message signal. Okay. So apart from what will happen, I will add another bit. Okay. So this bit will be called as parity bit. So again, its value can be 0 or 1. Okay. So there are two ways. One is called as odd parity. One is called as even parity. So in odd parity, what will happen? Here you need to count the number of ones in this message signal. So how many ones are there in this message signal? How many ones are present?
Two.
Two are present. So in an odd parity system, what will happen? Your number of ones should be odd. Number of ones should be odd. Then what I should add here such that ones will be in an odd number?
One.
Here one should be added. One should be added. Let's take another example. Suppose your message is 0111. Then what should be the parity bit?
Zero.
It should be 0. Already three ones are there. Okay. Similarly, in case of even parity, what will happen? Your number of ones should be even. Number of ones should be even. So what to do here? 0 needs to be added. Here 1 need to be added. So if it is an odd parity system, number of ones should need to be odd. If it is an even parity system, number of ones should be even. So let us take an example. I have taken a 8421 code here. I wrote from 0 to 9. Okay. Now this is my message signal. These are my message signal. Okay. Suppose the message signal is 40. I want to use odd parity. So what will happen to the message now? Total 5 bits. What are the total 5 bits? If it is already 40, it is an odd parity system, then what I need to add? क्या होगा? 0 लिखूंगा या 1 लिखूंगा? What I will write?
One.
It should be 1. Because number of ones has to be odd. There is no 1. So here 1 needs to be added. Now suppose 0001, 0001. Then what I should add? How many ones are there? Already single one is there. So what I need to add here?
Zero.
0. Okay. Similarly, so same this odd parities is written here. So verify everything is correct or not for all the combinations.
Yes, sir. Correct.
ठीक है? Is it correct? Okay. Similarly, for even parity, what will happen? Just number of ones need to be an even number. So just it's the complement हो जाएगा. Okay. So verify this also. ठीक है?
Yes, sir.
Now let us take an example. Now suppose my message signal is 1010 and I am using odd parity system. So from place A, what I should send? Means here in message signal I need to add a parity. Okay. So what will happen? What should be the total signal now? If it is 1010,
11010.
I need to add 1 because two ones are there. To make it odd number, 1 needs to be added. So this will be 11010. Now this data needs to be sent to place B. Okay. Now in place B, suppose I received 11011. Okay. So what happens here? In place B, I received 11011. Okay. So now what will happen? Whoever is sitting in place B, he will find out the number of ones. So how many number of ones are present there?
Even number of.
Even number of numbers. But person B knows that we are using odd parity system. So number of one should be a odd number. But what he got? He got even numbers. 4 number of ones, even number. That means he knows that whatever he received is not the correct message. Whatever we are getting in the place B, it is not correct. But can he rectify?
No, sir.
He knows that now, he knows that there is a problem, there is a error in the message, but he doesn't know in which position error is there. Unless and until he knows in which position error is there, he will not be able to find out. So this system or this kind of code is called as error detecting codes. Here we can find that there in this message error is there or error is not there, but we will not be able to correct it because we are not able to find out the message. Another example take here. Now suppose in place B he receives this 11001, 11001. Okay. So now how many ones are there?
Three.
3. Okay. So it is satisfying our odd parity system. We are using
Yes,
odd.
sir.
Only person B knows that which system we are using, odd parity system or even parity system. So here he is getting that 3 ones are there. So he assumes that it is a correct code. But is it correct? Is it same as what we sent in place A? Is it
No, sir.
same? It is not same. Okay. So actually what happens? Why this problem occurs? What is the difference between this example and this one? What is the difference between these two? this one and this one. What is the difference? Obviously, both are not same. Apart from that, क्या difference है? Think
So there
about.
is an
Think
there's an
about
extra one in the first one.
first one.
So there is an extra one.
Okay. Oh, okay. That's why this becomes
And
even now. So that's why we got that is error. Apart from that, both are different, obviously.
yes, sir.
So can you think about in terms of error? In how many bit error is there?
1 bit.
Here only in 1 bit error is there. Whereas here in this 2-bit error is there. Okay. So this system will be valid if only if 1 bit error will takes place. If more than 1 bit error takes place, it will not be able to find out. These are simple systems. So they are applicable only for 1 bit error. If error is there in 1 bit, then using this method we can find out error is there or not. If more than 1 bit error will be there, then we will be unable to find out. But here we are not able to correct the codes because we are not able to find out the position in which error is there. Let's take a last example. So question can become for any number of bits. Now suppose your signal is 10111. We want to use even parity system. Then what will happen? What will be your message now? If your message is this, you need to add the even parity. So
0 1
what?
0 1
नहीं
1
जीरो जीरो नहीं होगा. How many ones are okay? हाँ. How many ones are there? 4 ones are there. It is already a even number. So what will happen? You will add 0, then 1 0 triple 1. Okay. So this needs to be sent to place B. Okay. So we see here how to find the 1 bit error, but we are not able to rectify this. Okay. So again, same examples were given. Suppose something is reached to the output, like this question you can see. In an even parity system, which word contains the error? So here we are using even parity system. So this is you are getting in place B. So is it contains error or no error? We need to count number of ones. 1, 2, 3, 4. Even number. That's why no error. Here 1, 2, 3, 4, 5. It becomes an odd number. That means it contains a error. Same thing is for odd parity system. Now, how to rectify this? How to rectify the problem? How to overcome this problem? Okay. So to find out the error and also to rectify it, what to do? Tell me any example of any 4-bit signal. Any 4-bit signal you want?
1011.
1011. Okay. So when you are saying 1011, which one is your most significant bit and who is your least significant bit?
Both are one.
This one, this one.
Yes.
This is MSB or LSB?
MSB.
Most
MSB.
significant.
This is MSB. And this one is your least significant bit. So here to rectify the error, we need to go for error correcting code, which is called as a Hamming code. So different Hamming codes are available in our syllabus. We only have 7-bit Hamming code. So here what happens? We have 7 bits. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. So you can see here. So here 4-bit needs to be data and 3 bits needs to be parity. Means I need to add 3 parity bits. Previously we were adding 1 parity bit. Now we need to add 3 parity bits. Okay. So parity bit we can remember like this. It will become in the position 2 to the power 0. So 2 to the power 0 is 1. Then 2 to the power 1 is 2. 2 to the power 2 is 4. So parity bit is there in P1, P2, P4. So remaining position will be data. Okay. So D3, D5, D6, D7 is the data bits. Okay. So most significant bit will come here. Least significant bit will come in D7. So this will be 1011. Okay. So now tell me which parity system you want, odd parity system to be used or even parity system to be used? Any particular thing
Odd.
you want? Odd. We want suppose odd parity system. Okay. So what happens? Each parity bit depends upon the data bit. Okay. So this combination we need to remember. So combination is 1, 3, 5, 7. So P1 will depend upon the value of D3, D5, D7. So what is there in D3? D3 is 1, D5 is 0, D7 is 1. So how many ones are present there? How many ones are present? कितना one है?
2.
We want odd parity system. Okay. So number of ones should be odd. So what I need to add here? 1 or 0?
1.
1. So 1 will come here. Next. Next is to find the parity bit 2. Combination is 2, 3, 6, 7. 2, 3, 6, 7. Now, what is 3? 3 is 1, 6 is 1, 7 is 1. So how many ones are present here? Already 3 ones are present. It is an odd number. So what I should add in position number 2? क्या होगा? Already odd number
Zero.
is there.
Zero.
It should be 0. So this should be 0. Okay. Next. To find fourth parity bit, combination is 4, 5, 6, 7. So 5 is 0, 6 is 1, 7 is 1. Okay. So how many ones are there? 2 ones are there. So to make it an odd number, another one needs to be added. So I will add 1 here. So important thing is remember this. Okay. So we'll follow this method only. Okay. Others are also possible. So we'll go from this side to this side, P1 to D7, and to find the parity, these are the combination 1357, 2367, 4567. So we got that 10. My message will now become 1011011. So from place A, instead of sending 1011, what we'll send? We will send 1011011. Okay.
तो दोबारा समझा दीजिएगा तो
Just one thing here, what to do? We need to first of all to we have like previously we constructed this message. We constructed this message that this is the message signal. We find the parity here. So here we only added one parity bit. We added only one parity bit. So with the help of that, we are only able to detect the code. We are unable to correct the code because we are unable to find out the position in which error is there. So to solve that issue, we are going for parity bit. We need to add 3 parity bits. Okay. So this is a 7-bit Hamming code. So 4-bit will be data. 3 parity bits need to be added. So particular positions are there. This is parity bit P1, parity bit P2. This is parity bit P4. And D3, D5, D6, D7 is the data bits. So as you took the example of 1011, I wrote here 1011. Now, how to write this parity bit P1, P2, P4? For that, this combination needs to be used. 1357, 2367, 4567. So parity bit 1 will depend upon 357. Parity bit 2 will depend upon 367. Parity bit 4 will depend upon 567. So depending upon which parity you are using, odd parity or even parity, you need to add the ones. You need to add the ones. So we
Sir.
constructed this. Yes.
Sir, in the question it will be written or what? We need to use the odd parity.
Question it will mention for question will go on later on. Let us first try to understand the concept, then we'll see what kind of question can come. Because while solving this, I will not go in that way. Question will be different. I will explain in a different way, so that we will see that there is an error or not. Question will be straightforward, now. Okay. So first of all, any doubt up to this?
No, sir.
No, sir.
Okay. Now, this signal or this message will be sent to place B. Okay. So assume that error will be takes place. Okay. कोई भी एक पोजीशन में बताओ जहां पे कि तुमको एरर चाहिए कि सपोज प्लेस बी में this message reach हुआ, so that we'll be able to find out that whatever we'll decode it is correct or not. So any particular position you want error P1 to D7 US, any particular position
P2.
D2 to P2. अच्छा,
Yes, sir. P2.
this one. Okay, that means in place B what you will get, which data you will get,
1.
खाली that error means this will change, so this will be 1 1
Yes, sir.
double 1 0 double 1. Okay, so we now you knew that error is there in the place B. We as a third party we know, but in place B person doesn't know that error is there in the second position. Let us try to find out first of all there is error or not. If error is there, then in which position error is there. Okay, so in place B person, when he will receive the message, what he will do, again he will write those values 1357. Okay, so in 1 is there. Let me write here P1, P2, D3, P4, D5, D6, D7. So P1 is 1. Then D3 is also 1. D5 how much? 0. D7 1. Okay. So which parity system we used? We used odd parity system.
Odd.
Okay. So what happens here? That person will count the number of 1. So how many ones are there? 3. So it is a odd parity. So that means we'll write this as no error. No error. Okay. We'll write it as no error. Next. Next combination is what? 2, 3, 6, 7. What is there in 2? 1. 3, 1. 6, 1. 7, 1. Okay. So here, how many ones are there? How many
Even
ones
number
are
of
there? Even number of 1. That means it contains error. That means it contains errors. Next, 4, 5, 6, 7. 4 is 1, 5 is 0, 6 is 1, 7 is 1. How many ones are there? 3 ones are there, odd number. So it contains no error. It contains no error. 1 second. 1 second. Huh?
Okay, sir.
So what happens? This combination, we'll call this as C1. If it is no error, we'll write it as 0. This is, we'll write as C2. It contains error, so we'll write it as 1. This one we'll write as C3. And we'll write no error, so we'll write it as 0. Next, what will happen? We'll write down C3, C2, C1. What is C3, C2, C1? This will be 0, 1, 0. Okay. So if I'll convert it into decimal, what will get? What will get? 0, 1, 0,
2.
2. That means error is there in the second bit position. It needs to be rectified. So it needs to be changed to 0. It needs to be changed to 0. Okay. Now let us take another example. Another example. Tell any other position you want error.
D5.
5. 5 सेम ही हो जाएगा और एक कुछ बोलो.
So 2 places में error ले सकते हैं.
नहीं, one place, two places will go.
6.
6. Let us go for 6. Okay. So if error is there in this sixth position, what message will be received in place A? Sorry, place B. 1 0 1 1 0. उसके बाद क्या होगा?
0.
0 1. Okay. Now we need to check 1 3 5 7. So 1 is 1, 3 is 1, 5 is 0, 7 is 1. Okay. So what happens? 1 second. Let me erase this also. So what happens? It contains error or no error? How many ones are there?
No error.
No error. So C1 needs to be 0. Next, 2, 3, 6, 7. 2 is 0, 3 is 1, 6 is 0, 7 is 1. So how many ones are there? 2 ones. So it contains error or no error? It contains error or no error? It contains error because 2 ones, it is not an odd number. So C2 needs to be 1. Next 4, 5, 6, 7. 4 is 1, 5 is 0, 6 is 0, 7 is 1. Again 2 ones. 2 1 means even number. We are using odd parity
Error.
system. It contains error. So this must be 1. So if I'll write 1 1 0, what is the decimal equivalent? Decimal equivalent will be 6. That means error is there in the 6th position. Error is there in the 6th position. And we need to rectify this. So it needs to be 1. Okay. So in this way we can find out there contains error or not. Okay. Now suppose there won't be any error. Then what will happen? क्या होना चाहिए? अगर error नहीं होगा तो
सारा 0 आएगा.
0 आएगा. We are not using 0th position. We are not using anywhere 0th position. So when there will be no error, we should get everything as 0. Okay. So exactly same method should be applied for the even parity system. Okay. So let us take an example for that also. Same example of 1101. 1101 is given. Okay. And we'll go for the even parity system. So first of all, tell me what will happen to the P1. 1, 2, 3, 4, 5, 6, 7. Okay. D3 is 1, D5 is 1, D6 is 0, D7 is 1. Okay. First क्या होगा? 1, 3, 5, 7. So 3 is 1, 5 is 1, 7 is 1. If you are using even parity system, what needs to be added?
1.
So in place 1, 1 will be added. Next is 2, 3, 6, 7. 3 is 1, 6 is 0, 7 is 1. So already 2 ones, even number, 0 needs to be added. Last is 4, 5, 6, 7. 5 is 1, 6 is 0, 7 is 1. Already 2 ones, even number. So 0 needs to be added. So now your message is 1 0 1 0 1 0 1. Any particular place you want error? कहीं पे चाहिए error? किन particular position? कहीं पे?
4th place.
4th place means this. Sorry. This. So in place B, what you will receive? 1 0 1, then
1.
1 1 0 1. Okay. So this is first, second, third, fourth, 5, 6, 7. Okay. Now, what is 1 3 5 7? 1 is 1, 3 is 1, 5 is 1, 7 is 1. Okay. So 4 ones, 4 1 means even number. That means it contains no error. No error means what? C1 should be 0. Next, 2 3 6 7. 2 is 0, 3 is 1, 6 is 0, 7 is 1. So what happens? Again, even number, no error. So C2 should be 0. Last 4, 5, 6, 7. So 1, 1, 0, 1. How many ones are there?
3.
odd number, so it contains a error. C3 should be 0. So C3, C2, C1 is equal to 100. If we convert it into decimal, it is 4. So error is there in the fourth position. It needs to be rectified. Okay. So generally students used to do one mistake. What they used to do? They will do up to this correctly. Then what will do? They will write in a reverse order. If you write in reverse order, it will come 001. Okay, which will not be correct. Which will not be correct. So you need to follow this. Okay. So any doubt up to this?
No, sir.
So using this system, what will happen? You will be able to detect error in 2-bit. Error in 2-bit. We can detect error in 2-bit, but we can correct only for 1 bit. अगर 2 bit में होगा तो हम rectify नहीं कर पाएंगे. If there will be in 1 bit, we can rectify it. Okay. So short questions are possible out of this, and this is a long question. So now once you understand this concept, then we can go to the questions regarding that. What kind of questions can come? Okay. So two different kind of questions are possible. Okay. So one question is possible that a data bits will be given, then you need to form the 7-bit Hamming code. Okay. So like here we formed, in the first part we formed this from the data bit of 1101, we formed that this is 1010101. This can be a question. Or second kind of question is like this. The message below, coded in a 7-bit Hamming code, is transmitted through a noisy channel. Then decode the message assuming at most single error can take place. Assume even parity. Assume even parity. Okay. That means what? Now it is talking about the place B. In place B, you received this data 100, 100, 1001. This is 1, this is 2, this is 3, 4, 5, 6, 7. It is system is using even parity system. We need to find out, is there any error? If error is there, in which position error is there. So what to do again? Same procedure. 1357. What is there in 1357? 1001. So how many ones are there?
2.
2. So is it continuity error?
No, sir.
No, sir.
So no error. So C1 should be 0. Next, 2367. So 2 is 0, 3 is 0, 6 is 0, 7 is 1. Only 1. So error takes place. So C2 must be 1. Next, 4567. 1, 001. Again 2 ones, even number. So no error. So C3 must be 0. So next I will write C3, C2, C1, which will be 0, 1, 0. Decimal equivalent is 2. So error takes place in this second position. It needs to be rectified. So it has to be 1. So message will be 11010001. Okay. So is
Yes,
it clear? Okay. So next part is very easy. So you already know about this thing. So we'll go through all this. So next is logic gates and Boolean algebra. So in digital, whatever systems you will try to design, so logic gate plays the important role. They are the basic building block. Okay. It is called as logic gates because it has the ability to make the decision. Okay. So there are different logic gates are there, like AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate. Okay. So out of all this, these three are called as the basic logic gate: AND gate, OR gate, NOT gate. And these two are called as the universal gate: NAND gate and NOR gate. So with the help of NAND gate and NOR gate, will be able to implement all other kind of logic gates. Because of that, it is called as a universal gate. Because of this, it is called as a universal gate. Now, in logic gates, what happens? Your input and output can occur in two levels. What are the two levels? Either it can be 1 or 0. We can call them as on or off. We can call them as true or false, or we can call them as high or low. There are different naming. So either high or low, or true or false, on or off, or 1 or 0. So out of all this, basically we'll use only 1 and 0. Throughout the course, we'll use 1 and 0. Unless and until it is particularly mentioned about high or low, true, false, on or off. Next is logic system. Logic system are of two types, positive logic system and negative logic system. Now, in the initial class when I discussed, I told you that basically this logic 0 is nothing but a certain voltage level, and logic 1 is of certain voltage level. Okay. Now, what happens? Suppose I want to represent this 0 volt and 5 volt. So whoever is whoever is higher between these two, if we are representing them as 1, then it is called as a positive logic system. Positive logic system. So basically when you are representing like this, I told you that this is logic 0, this is logic 1. Ultimately, they are nothing but a voltage. Okay. So those voltage, if logic 0 is suppose 0 volt, logic 1 is 5 volt. So out of 0 volt and 5 volt, which is larger? 0 or 5?
5.
5 volt. That means it is a positive logic system. It is a positive logic system. In positive logic system, higher of the two voltage levels are treated as 1, and lowest one is treated as 0. If it is opposite, it will be called as a negative logic system. It will be called as a negative logic system. In that case, what will happen? Your 5 volt will represent it with as logic 0, and 0 volt will represent this as logic 1. So out of this, basically what we'll do, we'll unless and until mention, all the time we'll go for positive logic system. If it has to be negative logic system, then we will exclusively mention it. Okay. Otherwise, every time we'll use the positive logic system. So smaller one will be expressed as 0, and the larger one will be expressed as or presented as level 1. So okay, let me do one thing. I will share this PPT with you. Okay, so everyone, you go through this because these are very basics, and you already knew about it. This logic gates and its truth table. So you go through that. In next class, we'll be able to quickly finish it. Okay. So go through
Okay,
that
sir.
coming to next class. Before coming to next class. Okay. So do one thing. Write your roll number in the chat